Good afternoon.
Good afternoon.
So, how's everyone? Hey. So, let's see. We got uh who we've got missing in Mogyan.
Just Denon's gone.
Just Denon?
Yep.
Okay. I didn't see. So is Rhett's there?
Yeah, he's in the doorway right there.
Yeah, sorry.
Oh,
Someone
no
stole my
problem.
backpack.
All right. And let's see. Is Chloe gone? Or is that Chloe? Oh, there's Chloe. Okay. And looks like we're missing Aiden in St. John's. Yes?
And David is not here yet as well.
Aiden and David. Okay. Super. All right.
I guess Aiden is at a soccer game, but yeah.
Okay. Yeah, he emailed me. So that's cool. All right. So anyway, anything exciting
David.
going on? Oh, Aiden's who's there? Aiden? David.
David.
All right. Thank you. All right. So all right, so today we are going to work on 3.6, which is the chain rule. So that's pretty exciting. Anyone have any questions, comments, concerns before we jump in today? All right, so let's see. So Red, are you playing football this year?
Yeah, I am.
All right. Well, good luck in a losing cause tomorrow. I'm just kidding.
Thanks.
Anyway, no, I want you to do well. Just not to win. So, but I wish I could be there. That's my favorite game of the year, and I've got to be in St. George this weekend. So,
Oh, dang
anyways,
it.
so if you win, you can come talk trash on
I will.
on Monday. Okay.
I will.
All right. So, anybody else have any big plans for the weekend?
I'm having a bunch of family up. We're gonna do this like fall festival kind of thing, and we have, I think the majority of my dad's family is coming up, and that's a lot of people, and we're all just gonna party.
Very cool. Well, I saw a friend of mine took their kids to some thing in Snowflake. Maybe it was the corn maze or something. I don't know if they're having something. And then I think Sholo's having a big deal this weekend too. Anyway, the harvest parade or something. Anyway, so that sounds like fun. Anybody else do anything amazing? Do anything fun over the weekend?
I have a band competition.
And what kind of competition?
A band competition?
And where are you going?
Tempe.
Wow, so this must be a big one.
Oh yeah, well we have them like every weekend. This one's kind of big, but yeah.
So anyway,
We have state in like 2 weekends.
nice. Well, good luck to you.
Thanks.
Have you guys had good results so far this year?
Yeah, we got second place at our last one, so.
Nice. All right.
Yep.
Well, good luck. Good.
Thank
so
you.
what do you play?
I play the flute, but during marching season I'm the drum major, so I conduct them.
Nice.
So,
Okay.
yep.
Very cool. Well, so one of my what?
Oh.
Oh.
Nothing. I thought I was on mute. I'm sorry.
That's right. Well, one of the biggest travesties in all my teaching is one year. So I had in South Carolina, it was really important who was the valedictorian, because the valedictorian from every high school got a full ride scholarship to any state school. So the competition was fierce. And so when they had a class like this, like when I taught calculus and pre-calculus, those were weighted classes. And so I know that like Joseph City, and I think Mogollon, maybe changed it to make it this class a weighted class. because at least I don't know. Anyway, so that might be something if you guys care about being valedictorian or something, that or class standing, that might be something that you bring up to your student council or to your school board to make this class a weighted class if it's not. But anyway, going back to the story, so I had a student that was my top calculus student that year, and she was the drum major for the band. And they were, excellent, and they worked hard, and the band director really worked them hard. And she was amazing. Well, but because she took that class instead of like a college prep, like a weighted class, it actually cost her from being valedictorian. And here she was like, Miss Leadership, and she did all this stuff, and I was just so proud of her and all the work that she did. But she told me, she's like, Mr. Strong, if I would have taken blah, 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 I would have been valedictorian. And my heart went out to her. So,
Yeah, that'll probably be how it be for me.
yeah.
But, oh well.
Yeah, well, I hope not. But at least in Arizona, there's not quite the high stakes, because it was kind of cutthroat in some ways in South Carolina, and I kind of didn't like that. Here, if you're valedictorian, that's like a feather in your cap to get like a presidential scholarship or something like that. But it's not automatic. And if you're number 2 at a good school and you have good ACT scores, you're just as likely. So at least it's not quite that crazy. But anyway, and speaking of, is that as you get closer to application season, if any of you ever need like a letter of recommendation, I know it's kind of weird that because I'm not there with you, but I am your calculus teacher, and if you need one from a math teacher or just in general, don't hesitate to shoot me an email and let me know. But what I do ask is that you send me like a resume, because then I can put things in it like that you're the drum major or something, things that I wouldn't normally know. But a lot of things like that with leadership, if you mention specifics in a letter of recommendation, it carries more weight than to just sort of a generic, oh, this person's great type thing. So I'm just throwing that out there. If any of you would like me to do a letter, just let me know. Okay? All right, well, let's do some math. All right, so the chain rule. All right, so the chain rule is kind of another rule for doing derivatives, and it's actually really a huge time-saving rule, okay? So to take the derivative of a composite function, so a more complicated function, we're going to use the chain rule, okay? So an example of a composite function is when you put a function inside another function. So like the f of the g of x. So if I had x minus 1 squared plus 5. So where you put a function inside another function, that's a composite function. So the chain rule makes it so that we don't have to multiply this out, or it saves a lot. Okay, so here's kind of the out of math.
Mr. Strong?
Yes.
Sorry, I meant to ask this a second ago before you started teaching.
Sure,
but
go ahead.
have you been curving the tests? I don't know if you do that or not.
Well, I don't curve the individual tests, but I do curve the midterm and the final.
Oh, okay.
Okay, so and how I do that is basically whatever the highest score is. So if the highest score is 95, then I give everybody 5 points, that kind of stuff. So I curve the midterm and the final, and sometimes I actually do like an overall curve at the very end. Okay, but the individual ones I don't. So.
Okay.
Okay. All right. So this is the idea, is that, okay, like let's say you have these cogs turning, and you can see how like this cog will turn for every time this one turns, this one will turn twice, And then you can figure out how this one turns in relation to this one, okay? But the chain rule is kind of like, it's like we want to know how this one turns in relation to this one, where the spokes aren't even touching. And so to do that, it's kind of like you're saying, well, if we want to know how this one turns in relation to this, so in other words, for every one turn of this, this turns twice. And then if we multiply it by how this one turns in relation to this, for every one turn of this, this turns 3 times. Then if we multiply those together, then we get how this one turns in relation to this. So kind of now using like calculus ideas is if we think of dy dx is the change in y with respect to x, then that's going to be dy du, the change in y with respect to u, times du dx, the change in u with respect to x. So when this one turns, it turns this one. So you're multiplying them together. Now, from a fraction standpoint, okay, all right, you see that 1/2 times 3 over 1 is 3 over 2. So that would mean for every 3 turns of this, this turns twice. Okay? Now, from a calculus standpoint, what we're saying here is that dy dx, the derivative of y with respect to x, or the change in y with respect over the change in x, is equal to the change in y with respect to u times the change in u with respect to x. So it's kind of like these du's cancel, and from a fractional standpoint. And so when we're doing the chain rule, usually we want to write our derivatives like this. And so instead of y prime, we write it as dy dx. All right, so let's see if you can figure out the fractions, okay? So if dy du is -1/3 and du dx is 3/10, see if you can figure out what dy dx is. All right, so Hannah W., what do you think?
-1/10.
That is correct, okay? Because you have -1/3 times 3/10, and so then when you multiply it, cancel the 3's, and so you'll get -1/10, okay? So again, it's kind of like where the 3's are canceling, it's like the du's are canceling, so you get dy dx is dy du times du dx, okay? So using the chain rule, we can take the derivative directly instead of having to use a binomial expression, okay? So what I mean by that is, so instead of having to do this y equals x plus 5 to the 4th, instead of multiplying all that out and using the product rule and the product rule and then the big product rule, okay, that would just be insanely difficult. I'll just tell you that right now. The chain rule makes it super easy. You can do it in your head without all that awful algebra. Okay? So, this is kind of how I think of it. And I don't know if this really works for the students. It seems like a lot of students don't quite understand my brain. And it turns out maybe that's a good thing. But this is how I think of it, is instead of a binomial, I just think of this as blob, okay? Just some kind of blob, okay? Just a blob. And so the derivative of blob to the 4th power, okay, All right, we're used to this part of the power rule, which says you bring the exponent in front. So it's 4 blob to the third. But then, and this is the chain rule right here, is you multiply by blob prime, by the derivative of blob. So blob is some binomial or a trinomial or whatever. Okay? You multiply by the derivative of the blob. So this is how I think of the chain rule. Now I'm going to show you ways that how the book writes it, but this is what I think of. All right, let's see. Did I get the Okay. So this is kind of the idea. All right, we know how to take the derivative of this term by term using the power rule. Okay? So that's not the chain rule. This is just the power rule term by term. Okay? But suppose this function is written like this. Okay? So instead of multiplying this out and doing the algebra, what we can do now is the chain rule. Think of this as blob squared. So the derivative of blob squared is 2 times whatever's inside the parentheses. You don't change that. To 1 lower power, so it'd be to the first. And then times the derivative of the blob, the derivative of what's inside the parentheses. So the derivative of what's inside the parentheses is 6x plus 0, or just 6x. And now we can distribute the 2 and the 6x and get 12x. And since this is just to the first power, we could actually distribute that too. And so then we get 36x cubed plus 12x. And see, that's actually what we got up here before when we just when we had it already multiplied out. Okay? All right, so let's see if you can do practice 1. All right, David, what do you have?
I got 12 in the parentheses, or 12 outside the parentheses, and then in parentheses it's 2x plus 5, and in parentheses to the 5th power.
That's it. Good. So this 2 right here, so that's the new part today, is that you have to multiply by the derivative of the inside part, which is 2. And then you'd multiply the 2 and the 6 together, just like David said, and get 12. Now, you cannot distribute the 12 in this case because this is to the 5th power. So you said it just perfectly. Okay? Any questions? All right. Well, that's the chain rule. All right. So the chain rule can be used to determine velocity from the position function. So just all the applications that we've done with the derivative, now we'll have we'll have functions that might require the chain rule. Okay, so if I have y equals the cosine of x squared plus 1, so let's say this is the position function, and I want to know what is the velocity, then I just take the derivative. And so y prime equals, okay, so the way I do it is I kind of cover up the blob. So whatever's in parentheses, either mentally or physically, I'll just cover that up and say, okay, the derivative of cosine is negative sine. So I'll do negative sine of blob. But then I multiply by the derivative of this inside part. So the derivative of x squared plus 1 is 2x. Then I bring the 2x in front with the negative, and so then that's my final answer. And so then that's the velocity. Okay? All right. So go ahead and try practice 2, please. All right, Nathan, when you've got it.
Negative 26.279.
Beautiful. Okay? Negative 26.279, and the units would be meters per second, the velocity. All right, any questions on that? So you take the derivative, plug in the 2. Okay, it is sometimes...
Hey, Mr. Strong, can you
Yeah.
go back?
Sure.
Thanks.
Do you want me to go through it, or you just want to copy it down, or?
Do
Could you just go through it real quick?
Sure. Okay, so the derivative so s prime would be, so you bring down the 20. The derivative of cosine is negative sine, 2t plus 3. And then you multiply by the derivative of the inside part, which is 2. So 2t plus 3 times 2. All right, so now bring the negative in front and the 2 in front. So that's negative 40 sine 2t plus 3. And now you plug in 2 for t. So s prime of 2 is negative 40 sine of 2 times 2 plus 3, or 7. Make sure you're in radian mode, and then you got it. Okay? Okay, so it is sometimes helpful to think of the chain rule as differentiating the outside function evaluate at the inside function, and then multiply by the derivative of the inside part. So like when I write the blob prime, okay, that's like the derivative of the inside part. Okay, so let's say I have y equals sine of x squared plus x. Again, I just cover up this part and say the derivative of the sine is cosine. So it's going to be cosine x squared plus x. Now the chain rule says now you do multiply by the derivative of the blob, the derivative of the inside part, which is 2x plus 1. And then think of that as a okay, Red, are you paying attention or are you just playing a game?
No, sorry, I was paying attention.
Okay, all right. Okay, so then you bring this up front and then you kind of write it like that. Okay? All right, so go ahead and try practice 3. All right, so Chloe, when you've got it.
3x squared plus 2, and then negative sine x cubed plus 2x.
Okay, good. So probably what you want to do is where you have the negative sign, you don't want to confuse the reader or the grader to think it might be a negative. So usually when you have a negative, let's multiply by the sign, put it in front, either like this or even distribute it through that first little polynomial. But do you see how if you have it here, somebody might think it's like minus sign. And so if you have that negative, just bring it up front. Okay. All right, any questions on that? Anyone like me to go through it? All right, good job, Chloe. All right, we sometimes have to use the chain rule more than one time, or you could just write repeatedly if you want to. So you think of it as like another link in the chain. You've got to keep working till you get through to the very inside part. Okay, so let me show you what I'm talking about here. All right, so here when you're doing the derivative of tangent, whatever. So just cover this up. Say the derivative of tangent is what?
Secant squared.
Secant squared. So it's going to be secant squared of this whole thing. Okay? So you say y prime equals secant squared of this whole thing. And now you look at this blob, this inside part, and say, what's the derivative of 5 minus sine 2x? Well, the derivative of 5 is 0. The derivative of sine is cosine, so it'll be negative cosine 2x. But now you got to use the chain rule again because the derivative of 2x is 2. So you had to use the chain rule twice. Once when you're taking the derivative of 5 minus sine 2x, and then another time when you're taking the derivative of 2x. Okay, and so now let's look how you clean it up. So because this is to a power, usually you'll write the cosine first. And let's put the negative in front and the 2 in front. So we'll write it as negative 2 cosine 2x, and then the trig function that's to a power, secant squared 5
Wait, why is
minus
the 2
2x.
there?
The 2 here?
Oh my god.
This 2 right here.
Is it from the 2x right there?
Yeah, it's from the 2x. So the second use of the chain rule. Okay? All right. So I'll leave that one up there. You guys try practice 4.
I didn't get all the way through it. It was on me, wasn't it?
Yeah.
Yeah, but I got part of it, I think.
Okay. So tell me how far you got.
Negative sign, and then 10 minus tangent 2t times negative secant squared times 2.
Well, negative secant squared of 2t.
And then the 2.
And then the 2.
Oh, okay.
Because you got to take the derivative of 2.
Yeah, so negative sign of all of this, 10 minus tangent 2t. Then times the derivative of 10 minus tangent 2t. So the derivative of 10 goes away, so that's just 0. So then the derivative of negative tangent 2t is negative secant squared 2t. And then you multiply by the derivative of the 2t, which is 2. Okay? All right, so then when you clean it up, though, see, when you bring this negative in front, it already has a negative, so the negatives will cancel. And then you bring the 2 in front, so then you just get 2 sine 10 minus tangent 2t times secant squared 2t. Now, oh well, okay. Now, the thing that's a little tricky, okay, is that, like, let's say that if, like in the book, they write tangent of 2t, or they might write tangent of 2t. Okay, those mean the same. The argument is 2t. The thing is without the parentheses, some students forget to use the chain rule. Whereas with the parentheses, students tend to remember the chain rule more often. Does that make sense? That you got to multiply by the derivative of the inside part. So you just got to watch that. If they don't put the parentheses, just know you got to still use the chain rule on that type of problem.
And would it be the same thing if you put the secant squared 2t before the sign?
Yeah.
Okay.
Yep.
And then going on with that, if you put the 2 with the secant, that wouldn't matter either, would it?
It wouldn't, but you would want, so I wouldn't care which of these was first, but typically you put the 2 in the very front if there's a coefficient. Okay? So thank you. You guys, those are awesome questions. Okay. All right. Here we go. Okay, if n is a positive or a negative number, and the function of u is u to the n, then the derivative of u, f prime of u, is you bring the n in front, u to the n minus 1 times u prime. Okay? So this is saying that really as I taught you the power rule, technically the chain rule should always have been part of it. I mean, the chain rule works with the power rule. Okay? So let me give you an example. Okay? All right. Now, this is another way of saying find the derivative. So d dx of this function means take the derivative of this function. Okay? So it's something to the 7th power. So then the derivative would be, you bring the 7 in front times the function to the 6th power, and now the chain rule says now you multiply by the derivative of the inside part, which is 15x squared minus 4x cubed. Now, because there's not an exponent on this, then usually you'll distribute the 7 through and write that in front. Okay? So 105x squared minus 28x cubed times 5x cubed minus x to the 4th quantity to the 6th. All right, so go ahead and try practice 5a.
That's not a 15.
Where did the 15 go?
We multiplied the 7 by that. So you would distribute this. You can't distribute the 7 through here. You know what? Maybe it would be better if.
Oh, okay.
Here, let me throw in an extra step here. Okay. So if we write the other one first. So 7. So 7 times 15x squared minus 4x cubed times 5x cubed minus x to the 4th quantity to the 6th. And then I just distribute the 7 through on the first one because there's no power on that one.
Okay, thanks.
You bet. All right, so just do A for me. Practice 5A. Well, I don't know what's going on here. All right, so Rachel, what'd you get?
So I got 120x to the 4th minus 18x to the 2nd times 4x to the 5th minus x cubed, and then that's to the 5th power.
Yep, that's it. Great job. Any questions on that? Okay, now let's. Okay, so now one like this. Okay, now you could use the quotient rule on this. So this is kind of, originally when we did a problem like this, we used the quotient rule. But now we have an easier way to do it with the chain rule. So what you do is think of this as 3x minus 2 to the minus 1 power. Okay, and now so instead of using the quotient rule, you can use the power rule with that. So bring the negative 1 in front times whatever to one lower power to the minus 2, and then times the derivative of the inside part, which is 3. And then you just clean it up, and so you'll have negative 3 in the numerator, and then times 3x minus 2 to the minus 2, which then you can bring that back and make it a fraction like the original problem was. Okay? All right, so see if you can apply that to practice 5b. All right, Hannah Z. What do you have for that one?
Negative 5 over 5x plus 2 to the second power.
That is correct. Good job. Would anyone like me to go through that one?
Subtract.
Just the second half, please.
Okay. So, all right. So when you get to here, you bring the 5 and the negative 1 together. And then 5x plus 2 to the minus 2, use the elevator rule and bring that back down to the denominator. Now, this is the same thing as this. It's just that usually if your original problem is a fraction, your answer you should write as a fraction. Okay? All right. Okay, so to find the derivative of y equals the absolute value of x, what you want to do is rewrite it as a piecewise function. Okay? So, because you're doing basically, because it goes in halves, if x is positive or negative. Okay? So, because as it is, the absolute value of x is not differentiable. Okay.
Could you go back to that last slide, please?
Yeah, sure. Just
Thank you.
rewrite it as a piecewise function.
Okay, thank you.
Sure. So, okay. So what you do is you imagine that there's these two pieces of it. Because if x is positive, see, this is the piecewise function. If x is positive, then the absolute value of x is just x. And so its slope, its derivative is 1. If x is negative, then its slope is negative 1. It's the opposite of x. Okay? And then, but at x equals 0, it doesn't have a derivative because the left and the right hand derivatives wouldn't match. Okay? So let's just kind of do the practice 6 together, so you understand what I'm talking about. It says find the slope of the line tangent to 2x plus 3. Now, it doesn't say exactly where, so this just means find the derivative. It's just another way of saying find the derivative. Okay? So you imagine two cases. So if x is positive, greater than or equal to 0, then the absolute value of x is equal to what? If x is positive. Then the absolute value of x is equal to so like if x is positive, the absolute value of 5 is equal to 5.
5.
Five.
So it's just positive x, right?
So it's just positive
Yeah.
x. And in case 2, if x is less than 0, then the absolute value of x is equal to the
Positive
opposite,
x.
negative x, if it's negative. Okay? So in this case, you replace absolute value of x with just x. In this case, you replace absolute value of x with negative x. And so then the equation becomes negative 2x plus 3. So when x is positive, then what's the slope here for the red part?
2.
2.
And for the green part?
Negative 2.
Negative 2. Okay? And so it's going to have the two pieces. All right? So to find the slope of the tangent line, take the derivative. Okay? So see if you can do practice 7. You take the derivative and then plug in pi thirds into your derivative. All right, so Nathan, when you've got it.
Negative 2.813.
Negative 2 let's see. I got negative 2.71. So, I don't know, maybe someplace you rounded. Did you like plug in pi thirds and round? And plug that in, or did you actually use pi thirds when you plugged in for x?
I kept it.
You kept
No,
it.
wait, what? I'm really confused. Let me look.
All right, well, we're almost out of time. I want to just make sure that we don't have any calculator issues. So maybe everybody write that answer down and make sure that you can get it. And we'll start there on Monday. And then we just have a little bit talking about why we use radians instead of degrees. And so we'll kind of finish this up and start in on 3-7 on Monday. Okay? All right, well, have a great weekend, you guys. Thanks for working hard.